solving exponential equations by taking logs of a specific base of both sides. So we're going to use the base of the exponent to determine which base of the log we're going to use. The first thing we have to do is make sure we get the exponential part by itself. So there's 3 to the 4x. That needs to be alone before I can use the log base 3. So the base is 3, so I'm going to use log base 3. So first I need to divide by the negative 2. So 3 to the 4x equals positive 6. And now I have the log base 3 of 3 to the 4x equals the log base 3 of 6. So I'm using log base 3 because the nice part about that is the left side here just becomes 4x equals the log 3 of 6, and I can divide by 4. So x equals the log base 3 of 6 over 4, which in order to put it in my calculator, I need to write it as log base 3, oops, sorry, that's not right, log of 6 divided by log of 3, and then I have to divide by 4. That's what I'm going to do in my calculator. Really, though, it's multiplying by 1/4, so that's really times 1/4. So I end up with log of 6 divided by 4 log 3. Remember, we're trying to get you to see different ways to write all the different problems so that when you're on the SAT, you don't get stuck because they decided to write it differently. And then let's do this in our calculator. When I plug it into my calculator, make sure I'm closing parentheses around the 6. Make sure I'm putting it in right. I get 0.4077. All right, let's look at the next one, an inequality. This 9 needs to move first, so I'm going to subtract 9 from both sides. So I get 5 to the x minus 3 is less than 7. And I'm going to take the log base 5 of both sides because the base of my exponent is a 5. So log base 5 of 5 to the x minus 3 is less than log base 5 of 7. And our left side just becomes x minus 3 because log 5 and 5 to the power of x are inverses. Log 5 of 7. And then I'm going to add 3. So x is less than the log base 5 of 7 plus 3. Again, for my calculator, log of 7 divided by log of 5 and then add 3. And that's going to be, put it in real quick. When I do that in the calculator, I get x less than 4.209. So any of these are proper ways to write the answer. So make sure you know how to convert from one to the other. This is your change of base formula from log base 5 of 7 to log base 10 basically of 7 divided by log base 10 of 5. And we do that because that's how we put it in the calculator, because a large portion of our calculators don't have the cheater key, which allows you to do log base 5 or change the base of the log. So the last problem is 24 equals 3 times 10 to the 2x minus 1. I want to remove that 3, so I'm going to divide by it. It's being multiplied. So 8 equals 10 to the 2x minus 1. Now here I would choose common log because it's base 10, and that's going to be helpful. So log of 8 equals log of 10 to the 2x minus 1. And log 8 equals 2x minus 1. We can add 1. Log 8 plus 1 equals 2x. There's no parentheses there because that's not in the log. And then we get the log of 8 plus 1 divided by 2 equals x. And then we're going to plug that in to our calculator. And when I do that, I get x is approximately 0.952. Okay.